So see, during last lecture, we started with the introductory part of the composite material. And starting with the introductory part of the composite material, we have seen the definition of composite material, how composite material is different from pure metal or alloy, how it is distinguished from alloys. Then the terminology related with the composite material, inside which what is matrix, what is reinforcement, then which are various types of matrix materials, which are various types of reinforcement materials, classification of composite material, uh, the terms which are associated with the composites, that fundamental things we have seen. Now we are coming to the end of this first chapter, the fundamental or basic of this composite material, which we are studying in the first chapter. Inside that, now we are coming to the last part of the first chapter, that is the applications of composite material. Is it okay? As far as concern with these different types of composite materials, for example, we have seen that polymer matrix composites, metal matrix composites, ceramic matrix composites. So each and every type of composite material has its different application area, and that particular composites are used in that applications. Now, if we take the example of polymer matrix composites, then application of polymer matrix composites, these initially we can find in the sporting industries. So the tennis rackets, from that these applications will start, and polymer matrix composites have large application domain in space shuttle system. So rather than enumerating only the areas of in which polymer based composites are used, now let us take one by one example of the polymer matrix composite. In aircraft industries, for example, in military aircraft industry, the polymer matrix composites are largely used. Percentage of structural weight of composites. So F12S in 1970, now polymer matrix composites are 30% in the aircraft industries. Means we can see in 1970 there was only 2% utilization of the composite material, but after that in near about 2000 that percentage increased up to 30%, and presently that is again higher than that. Aircraft industry is the industry because we know that the highest advantage of polymer matrix composite is in its weight saving, and in aircraft industries weight matters a lot. So it is predicted that if suppose 1 pound is approximately half kg, so that much weight if it is reduced from the aircraft, then commercially it will have the advantage of 1300 gallon liter of petrol. 1300 gallon liter of petrol means that is near about 4500 liter, near about that much amount of petrol any aircraft can save with 1 pound lesser weight in commercial aircraft. Means how the weight has impact in aircraft, that we can understand. This is one simple example. So from that point of view, the weight saving material is polymer matrix composites, and that's why it is largely used in case of uh, commercial aircrafts. Is it okay? Use of composites is limited to secondary structures, means rudders, elevators made of graphite epoxy. Now, we always heard the different names of the aircraft. Boeing is one of the company. We know what is Boeing company, because many times we book the tickets, or many times many travelers book the tickets from different aircraft companies. And Boeing is very old company. Inside that, in the military aircrafts also that work. So in military aircraft, if we take the example of Boeing 767, so in that the Kevlar graphite epoxy composite is used. So Kevlar graphite combined with epoxy as material. Epoxy as a matrix material, Kevlar as a reinforcement material, and graphite also reinforced material. So like graphite, Kevlar is also one of the kind of material which is introduced inside the epoxy, and this hybrid composition. So the Boeing 767, in that the landing gear doors are made from Kevlar graphite epoxy. Is it okay? So use of composite, because of its safety concerns, so that are limited to secondary structures, means rudders, elevators, gear doors, etc. So composites are used in panels, flooring of aeroplanes. Primary structure of all aeroplane, all composites, means fan is also made from this tail fin Airbus. Airbus is one of the kind of example of this aircraft. So Airbus A310 or 300. So that is also have more applications in the composites. So polymer matrix composites have applications in air. Okay. So we can see how these are the advantages from application point of view. In World War II also, even with useless made epoxy that were used. Now here you can see one figure. This is aircraft engine cowling. This is okay. So this ADP, here it is written. This figure you can see here. That aircraft engine cowling. Here you can say the model of aircraft is shown. So that is German fighter plane, inside which glass epoxy mold fuselage and wing spars graphite epoxy that are used. So graphite epoxy and glass epoxy composites that are used in this model BF109. Is it okay? Likewise, here you can say Bell V-22 Osprey. Is it okay? This is also one of the military aircraft, inside which large amount of this graphite epoxy and glass epoxy both are used. Similarly, this in this helicopter, so in that helicopter and tilt rotors, the graphite epoxy and glass epoxy rotor blades that are used. Is it okay? So previously there was 100% metals, but nowadays these are replaced by these composites. Is it okay? So how these applications are there in aircrafts that we have seen. Then in space also these polymer matrix composites are used. So two factors makes composite the material choice of space application: high specific modulus and strength. High specific strength and high specific modulus, these two things are different. Strength to weight ratio, that is specific strength, and modulus to weight ratio, that is the specific modulus. Is it okay? So high specific modulus and high specific strength, these two things are there, due to which these polymer matrix composites are used in the space industries. Is it okay? The polymer matrix composites have again one advantage of dimensional stability also. Means coefficient of expansion or coefficient of with reference to temperature, contraction and expansion. For both cases, the polymer matrix composites generally doesn't respond like metal, because in case of metals, expansion or contraction is large, and that's why the dimensional stability, because we know that in the space there is always variation in the temperature, large variation in the temperature exists, and due to which dimensional stability is more essentially required, and that becomes one of the advantage for this polymer matrix composites in space applications, and that's why high specific strength, high specific modulus, and dimensional stability. These are three advantages of polymer matrix composites, due to which these are used in the space. Is it okay? Then graphite epoxy, honeycomb, these are also one some of the type of composites. In honeycomb structure, reinforcement is in honeycomb shape, and then top and bottom plates of metals are given. The weight saving over conventional metal alloys translates to higher payloads. So space shuttle in that graphite epoxy, so that is the primary and weight saving material. So see how the graphite epoxy has applications, because in aircrafts also we have seen the many applications for graphite epoxy and glass epoxy, and in space also this graphite epoxy is useful. Is it okay? Now if we consider the electronic application here, so we can see the figure, and here you can initially just see this figure. With this figure you will come to know how the different composites are used in this particular application in space shuttle. Okay, so this is an example of space shuttle. Now, side by side, we will see the applications of different metal matrix composites also. So here, the fuselage truss part is here. Here you can see this is the truss part. On sides, this portion is shown. So this is the truss part. Mid fuselage truss members which are present on both sides. So for that, high specific and high strength stiffness is required, where boron aluminum is used. Is it okay? So boron aluminum, that is used here. So mid fuselage truss members, which is having high specific strength and stiffness. Then here you can see that silica insulation. So around this, because at the same time what happens that in order to protect the large temperature, near about 350 pounds of this weight saving advantage it will get, and silica insulation is there. Then here you can see that in this region, this graphite epoxy pods are used in this region. Then here you can see that boron epoxy reinforced titanium truss member is shown. Here again this truss member is shown. So that is boron epoxy reinforced truss member. Then here you can see the sleeves, cryogenic lines that are shown here. The fiberglass, polyurethane, resin, lightweight composites are used. Then here fiberglass, epoxy, resin composites are used. Then here you can see the graphite epoxy bay doors, high strength to weight ratio. Here graphite epoxy doors are also used. Means as already stated, these all composites not forming the core part of the engine, but whatever the structural portion or secondary portion, that is largely manufactured with the help of composites materials. So fiberglass sandwich face sheets, that is shown here. Is it okay? Then pressure vessel fiberglass overlapping is shown here. Means you can see here how much applications that composite possess by this space shuttle system. Then, as far as concerned with this electronics and telecommunication, is it okay? In case of electronics and telecommunication area, where high gain antenna for space station that uses sandwich made from graphite epoxy facing with an aluminum honeycomb core, means in order to have the strength, the honeycomb of aluminum, honeycomb means the structure, diagonal type of structure, honeycomb like of structure. So that structure is made from the aluminum and graphite epoxy facings. So this is the sandwich type of composite material. So in case of sandwich type of composite material, the graphite and epoxy are combined in order to form the facing, and aluminum is used as a honeycomb, means basal made in between the structure of honeycomb is present at the top layer and at the bottom layer. So graphite epoxy facings are made. Is it okay? Means inner material is considered a core and surface material is considered to be facing. In case of sandwich composites, core and facing, these two terminologies is used. So core is the part which is internal part and facing is the part which is the surface part. And by combining this core and facing, the composite material is developed. Is it okay? So sandwich made of graphite epoxy facing with aluminum honeycomb core is used. Then antenna ribs and struts in satellite systems are used from graphite epoxy for their high specific stiffness and dimensional stability. Here you can see this high gain antenna for space station. Is it okay? So this is the antenna. You can observe here this antenna you can see here. So this particular high gain antenna for space station that is used. Is it okay? So this is also application of the composite material. Then composites which are newly launched, so spaceship. So for spaceship, here we can see that figure 1.24. Here we can see here after this one, here it is the spaceships. So this is the first privately manned vehicle. Is it okay? And this goes to beyond the Earth's atmosphere. So here you can see the scaled composites in which this composite material was used. Is it okay? So this is one of the application in case of space also. Is it okay? Then sporting goods, means sporting industry. Now only we have seen the example of sports. So one more example of the graphite epoxy again. Once again, see how graphite epoxy has different applications. So this graphite epoxy is now replacing the metal. So in golf club also, the shafts are mainly coming with the use of graphite epoxy, because whatever the shafts are used during sport, that shaft must be, we can say it as, it should not be heavy material, it should be light material, because the player carries that golf club shafts with their hand, and that's why the sticks should be lightweight. So metals always have higher densities, and that's why graphite epoxy that is replacing the metals in golf club shafts and decreases the weight and use the saved weight in the head. So this increases the head weight and improve the driving distances. Is it okay? So like this one can example of the sporting. Then bicycles uses hybrid construction of graphite epoxy composites. So our regular bicycles which we use in our daily applications, so that uses hybrid construction of graphite epoxy composite wound on aluminum tubing or chopped S glass reinforced foam. Means bicycle must be lightweight, no doubt. Everybody wants that kind of bicycles with lightweight, and that's why previously metals were used, steel was used in case of bicycles. But nowadays, if you see, the bicycles uses the hybrid composites, and in that hybrid composites, graphite epoxy composites which are wound on aluminum tubing. A tube of aluminum is there, and around this, the graphite epoxy composites are wound in order to increase the strength of that construction or that bicycle frame. Number of times, yes, glass reinforced foam is also used. Is it okay? Graphite epoxy composite increases the specific modulus of the tube and decreases mass of the frame. So near about 25% weight saving that is happen due to the use of this kind of composition, aluminum pipe and hybrid construction of graphite epoxy composite around them. Composites also allows frames to consist of one piece, which improves fatigue life and avoids stress concentration. Is it okay? So we can see this one example. Then as far as concerned with tennis and racket ball. So tennis ball and racket ball. That is also rackets. That is also example of graphite epoxy frames. Is it okay? So in sporting industries, how this Kevlar, glass, graphite, so these are combined that we know. So one example we started with the aircraft, then we took the example of space shuttle, then third we have taken the example of sporting industries, and then this one example of the medical devices. Is it okay? One more example, 1 minute. So here one more example, if we take then medical devices. So applications here include the use of glass Kevlar epoxy lightweight face mask for epileptic patients. Artificial portable lungs are made of graphite glass epoxy. So see, in medical devices, how these composite materials are becoming useful. Artificial portable lungs that are also made from graphite glass epoxy so that a patient can be mobile. X-ray tables made of graphite epoxy facing sandwiches are used for their high stiffness, lightweight, and transparency to radiation, because we know that transparency to X-ray radiation is very, very essential. Unless and until the transparency is not happening, the X-ray cannot be possible. So other materials out of which if we use the graphite epoxy facing sandwiches, then that are lightweight and transparent for the radiation. So as far as concerned with medical devices, which two applications we are observing now? Glass, Kevlar, epoxy, lightweight face mask. So face masks are also used from this glass Kevlar epoxy. That face masks are always used in order to protect the face for the epileptic patients. So for patients also that is useful. So face mask, then artificial lungs, X-ray tables. These are the examples. Is it okay? So in medical field, in that way, the composite materials are useful. So we started with the space aircraft applications, then space applications, sporting industries, medical applications, and now marine applications. So fiberglass that are used in the boats, that is well known. The hybrids of Kevlar glass epoxy are now replacing fiberglass for improved weight saving. Is it okay? So you can understand in marine application how it is useful. Fiberglass, so that is used in the boats, and hybrids of Kevlar glass epoxy. So Kevlar is reinforcement, glass is also reinforcement, but hybrid of Kevlar and glass that is added inside the epoxy. Epoxy is the matrix material. We are going to observe the manufacturing processes of the composite material later on. During that manufacture of the composites, we will detailed observe how the composites are manufactured. But before that, as far as application point of view, so Kevlar glass epoxy, that is one hybrid composition, and the hybrids of Kevlar and glass which are inserted inside the epoxy, so that are now replacing fiberglass for improved weight saving. Then it has an advantage of vibration damping. So Kevlar glass epoxy has an advantage of vibration damping. This absorbs the vibration and it has good impact resistance. Kevlar epoxy itself would have poor compression properties. Is it okay? So again, housing made of metal such as titanium to protect expensive oceanographic research instrument during exploration of sea wrecks are cost prohibitive. Now here you can see the titanium material is very costly material. So that titanium, there is an alternative to this titanium material. So previously the titanium material was used for housing manufacturing, and that housing was used as a protection. But nowadays this titanium material is not used. These housings are now made from glass epoxy. Is it okay? So for this, near about 69 megapascal, that much amount of pressure this material sustains. And we know the advantage of polymer matrix composites in case of marine application, that it is corrosion resistant material. Means any metal if we are using in the marine application, definitely corrosion is going to happen. But for polymer matrix composite, that is largest advantage, that it is corrosion resistance, because in case of metals, oxidation process happens, and due to the oxidation, corrosion happens. In case of polymers, the oxidation thing doesn't happens. There is no any chemical reaction of polymer with oxygen in order to have corrosion. And that's why this becomes one kind of advantage. So in case of marine applications, the housings of these ships, so that are previously manufactured from titanium, are now replaced by this glass epoxy type of composite material, as this is good corrosion resistance. Then bridges made of polymer composite materials are gaining wide acceptance due to their low weight. In case of marine applications also this is useful. So we started with aerospace, aircraft, then space shuttle, then sporting industries, medical equipments, marine applications, and then we are observing now the automotive applications. So as far as concerned with this automotive application, the fiberglass body Look, in case of automotive applications, if we take example of bike or car, automobile sector, so automotive applications of polymer matrix composites. So in addition, the Corvette has this glass epoxy composite lip springs. Here you can see the lip spring is here. Here you can observe this is the lip spring. So for that lip spring, number of times we use this kind of lip spring for different applications. In case of automotive applications nowadays, this glass epoxy composite lip springs are used. Is it okay? And fatigue life of more than 5 times that of steel. So see how this lip spring is having advantages as compared to means steel lip spring and glass epoxy lip spring. If we compare these two springs, then how you can see that advantage of this kind of material we are getting in case of automotive applications. Is it okay? So composite lip spring, that composite is again glass fiber and epoxy. Is it okay? So glass and epoxy composites. So that kind of composites give advantage in automotive applications for manufacturing the lip spring, and as compared to steel, this kind of material composite which is manufactured here, so this gives the advantage of 5 times more fatigue strength. Is it okay? Composite lip springs offer less chance of catastrophic failure. Now, catastrophic failure is one of the concept. In that concept, what happens? The failure happens with link. Means first of all, failure of surface, then integral part, then second part, then third part. Like this, with link, if failure happens, then that is the catastrophic failure. The composite lip springs offers less chance of catastrophic failure as compared to steel, and definitely possess the excellent corrosion resistance. Is it okay? So, by weight about 8% of today's automobile parts, so that are made from composites. So, including bumpers, body panels, and doors. However, in 1981, if we check, at that time, whatever the components were used in automotive sectors, nowadays its utilization is largely used, and now we can observe that in 1981, the whatever the bikes were available, now its weight has been tremendously reduced. Near about 50% of that weight of modern vehicle has been reduced due to use of carbon composite bodies. Means here is one of the more different application in case of automotive sector, that bodies of carbon composites that are also used in case of automotive applications. Then in case of commercial application, fiber reinforced polymers have many commercial applications. Okay. So what are the different applications we have? What are the different fields we have seen up till now? Aircraft, that is one of the field, aerospace industries, then space industries, then sporting, then marine, medical, and automotive. So these 6 examples we have seen. Now the 7th example, that is commercial application. So in pharmaceutical industries, okay, whenever the seamless surfaces are used in something, some places smooth and sealed surfaces are required. Is it okay? So that keeps the bacteria from staying and growing. In order to stop the growth of bacteria, these applications are for pharmaceutical industries used. So these composite materials are used in the pharmaceutical industries to handle that strong, rigid, chemically and heat resistant material. Is it okay? So glass fiber composites, glass fiber reinforced polypropylene. Is it okay? Here glass epoxy is not used. Now up till now many times we have heard the Kevlar, graphite, glass. Is it okay? So different applications of Kevlar, Kevlar epoxy composites, graphite epoxy composites, carbon epoxy composites, glass epoxy composites that we have seen. But in pharmaceutical industries, as far as concerned with this chemically and heat resistant and strong rigid material, the glass fiber reinforced polypropylene is used. Polypropylene is the matrix material here, and glass fiber is reinforcement material. So other applications include pressure vessel for applications such as chemical plants. So in case of chemical plants, pressure vessels that are manufactured, garden tools are there, then traditional metal tools are there, then children and people with physically challenged hands, foots that are also used. So that are also manufactured with different composite materials. Niglas name of the composite material, which is extremely lightweight and a durable type of composite material. So here we can see how many applications that particular polymer matrix composites possess. So we started with aircraft. In aerospace, how there is applications of the composite materials are there. Second, we have seen the application area in the space shuttle system. Third one, we have seen the applications in the sporting industries. Then fourth one, we have seen the applications in the medical device manufacturing or medical fields. Then fifth one, we have seen the applications area in marine sector. Then sixth, we have seen the application area in automotive sector. And seventh, we have seen the different commercial applications like the example of pharmaceutical industries. How in pharmaceutical industries, these polymer matrix composites that are used. Then as far as concerned with this metal matrix composites, is okay. So we are going to study in detail the manufacturing processes of the polymer matrix composites and metal matrix composites also. But here in this metal matrix composites, the manufacturing process, though it is different, applications are also different, because in case of polymer matrix composite, it has one advantage, one limitation. So polymer matrix composite have advantage of it's lightweight, but it has limitation of the temperature range, because for higher temperature range the polymer matrix composites would not work. But in case of metal matrix composite, if we see, so they have certain higher temperature regions where applications of metal matrix composites are possible. So naturally melting points of the metals are higher than polymers. So that's why metal matrix composites are more stronger for some higher temperature regions. Is it okay? So in case of space shuttle, the boron aluminum tubes are used in order to support the fuselage frame. So we have seen one example. Here also we have seen in case of this application, fuselage frame. Here you can see this figure we have seen here. In that figure you have seen what is the fuselage, because here you can see this is the portion. So in here at this portion, here you can observe, so this particular portion you can see. So here that is shown that boron aluminum mid fuselage truss member that is present here. Is it okay? So in case of this metal matrix composites, here we can see that in space applications like this, metal matrix composites have applications. Is it okay? So in space shuttle, boron aluminum tubes to support its fuselage frame that is used. Then in addition to decreasing the mass of space shuttle by more than 145 kg, boron aluminum also reduced the thermal insulation requirement because of its low thermal coefficient of conductivity. Is it okay? Low thermal conductivity. So here you can see what advantage was found for using boron aluminum. So previously that was manufactured with the help of metals, but as the boron aluminum tubes were used to support the fuselage frames, then here we got the advantage of reducing the weight of 145 kg. So it is not less small figure. 145 kg is very large figure, and by that much amount of weight, the weight has been reduced, and the thermal insulation requirement because of its low thermal conductivity. Is it okay? So boron aluminum, that kind of composite which is considered to be metal matrix composite, inside which metal is used as a matrix. In case of polymer matrix, polymer is used as matrix. So here boron and aluminum, that kind of composite is present, and this composite has advantage to use, not only reduce the weight but also due to its low thermal conductivity, that becomes one kind of advantage in space application. Is it okay? Then Hubble telescope, that is also uses carbon reinforced aluminum. See, carbon here is used as a reinforcement material. So here with the help of diffusion bonding, this material is manufactured. We can see the application of this Hubble telescope, inside which carbon that is added inside the aluminum. So carbon reinforced aluminum that we are using here. Matrix material is aluminum and carbon is added inside this. So carbon reinforced aluminum. One example we have seen the carbon boron aluminum. So boron aluminum, how it is useful in space. At the same time, carbon reinforced aluminum, that is also used in the Hubble telescope. That is also one of the advantage. Then in military applications, in missile guidance system, because their high dimensional stability is required. In missile guidance system, high dimensional stability is required. Means this dimension should not get changed with larger temperature also and for lesser temperature also. So that dimensional stability is required. In that case, metal matrix composite like silicon carbide aluminum, means silicon carbide is added inside the aluminum. Due to addition of silicon carbide inside the aluminum composite, it satisfies the requirement of dimensional stability. Is it okay? The geometrics of the components cannot change. Dimensions should not change with respect to temperature. So for that purpose, silicon carbide is added inside the aluminum composite, and that satisfies the requirement of dimensional stability. Here you can see this one figure is shown here. In that figure, this boron aluminum component. So see here, we have seen the example in case of space shuttle application, and you can observe here how this particular application is present here. Is it okay? So here you can observe this application, that boron aluminum component. Here also In gas turbine engine components, metal matrix composite is used. So here this example which is shown here, this is gas turbine engine components. So these are manufactured with the help of, here you can see this is used, this particular application which is manufactured with the help of metal matrix composites. In case of polymer matrix composite, we use the word that these composites are used for which application? These composites are used for secondary applications. But in case of metal matrix composite, high strength, low weight, and ability to perform at high temperature makes metal composite materials as a choice of gas turbine engine component. Is it okay? So gas turbine engine components that are manufactured with the help of this composite material. Then metal matrix composites are used in the transportation, that is in automotive sectors. For automotive engine, these composite materials are used. Is it okay? So high strength to low weight. So that is the advantage of metal matrix composite, and that's why these are the choice of gas turbine engine. Is it okay? So as far as concerned with this different in this table, you can observe that how the fracture toughness of composite material is there. Silicon carbide to alumina, silicon carbide to silicon carbide, only silicon carbide, aluminum alloys. So here you can see the fracture toughness, megapascal under root meter. So these are the epoxy, aluminum alloy, silicon carbide, like this, how this works here. Is it okay? So this is the application of metal matrix composites. Is it okay? And then application of ceramic matrix composites. So ceramic matrix composites are finding increased applications in high temperature areas in which metal and polymer cannot sustain. So metal and polymer cannot sustain at this location. These ceramic matrix composites are used. Is it okay? So with this today we will stop here. So anybody, any